This is a collaboration between Earthship Biotexture and Pangea Builders, and we have a natural sort of we have a goal, a mutual goal in common, which is to spread the idea of living off-grid and sustainably, and try to build as many houses as we can for people to live free from the grid and the system. And in the visitor center, I get the question all the time. So I want one of these homes, in this case an Earthship. What is the process that taking on clients at Pangia? What's just take me through, like, what's your first step? What's your next step?
Right. So we're Pangia Design Build. We do more than just Earthships and more than just buildings, and we'll probably get into that soon. And so we have we have architects and contractors and engineers on our team, on our staff, and so yes, it is a process. There's a lot of hoops to jump through. There's a lot of steps. There's a lot of third-party consultants. It is a bit of a labyrinth maze to start from the idea of wanting a building all the way through to permits and then the construction process and insurance and everything. So our design and build process is specifically designed to be a full service firm all the way through, from beginning to end, to guide the client, and we take care of everything. And so at the beginning, we have a couple of initial consultations by phone or Zoom, and we learn about what the client wants, what size building, what aesthetic, what look, what materiality. Like one of our clients now wants rustic modern. They don't understand what that means yet, but they like the idea. And so we're sent a number of images and ideas from wherever. And through understanding them, how they live, their likes, their dislikes, defining a statement like that, rustic modern. And so we arrive at an idea through mood boards and conversations about what they're looking for. It does not have to fit into a certain form factor. We can provide buildings that look and feel like anything they want, floor plans, layouts. When we understand where the building is, where the job site is, we understand the climate. And so that obviously informs that governs the design of the building, about what we can do in terms of making it completely off-grid or partial. And we can really get into that one. And then the client engages with us, and it's based on cost per square foot at an early estimate. Typical architecture fees are anywhere from 7 to 20%. We rarely go above 12% unless it's a really intense job. And then so we would, the first step is like schematic design, SD, and that allows us to land on a final floor plan. And then we start to get into design development, designing all the interiors, the materiality, the look, and the systems, all the plumbing, all the mechanical, all the gray water, all the catch water, cooling tubes, solar, everything. And then about halfway through that process, we'll start to price things out. We'll look at materials and subs and labor and logistics. And then so that we can, before we finalize DD, design development, we're running hand in hand and keeping synced with the client in terms of costs as decisions are made, from countertops to materials, whether it's rammed earth or concrete or whatever. So that when we're finished with the permit and construction set, the budget is pretty much finished. It's always an estimate until the day we actually go buy the materials. In light of COVID, things have been very volatile. Not so much anymore, but still. And as on our build side, we don't mark up anything. All of our books and accounting is all absolutely transparent. because the amount of time we deal with an expensive material is the same amount of time we deal with a lower price material. And so it doesn't feel right to just mark things up at 20% like a lot of contractors do. So we have a fixed fee throughout the whole job based on, say, 6 or 7 months. And if it goes to 8, 9, 10 months, the fee adjusts accordingly. And then we build it and turnkey. We even getting into custom furniture or bringing in furniture or whatever. So that's the quick description of the process. And during the build, we can do things from just construction administration, where we're doing a couple site visits and we're lining up, or even have nothing to do with local contractors. Like, we can design the building so it's concrete instead of rammed earth, which basically makes it any local contractor can do it. We spent, my father and I and our entire team at Earthship Biotecture has spent decades designing these systems so that an average tradesperson in electrical or plumbing or whatever can look at the drawings, a little 10-minute conversation with us, and then they can put in the system. So it's designed so that most anyone can really build it. So we do things from just construction administration to build the entire thing turnkey.
Now, what are the differences in localities regarding like what because I don't have a degree in architecture. I'm just learning on the job. What the stages to building a building, and but you need certain drawings to get the permits initially. Does that change place to place? Like what drawings you need?
Definitely.
And so, what is the range of let's just say not just like the boondocks where nobody needs any permits, but like most localities need what to get started?
Right. So, first, architecture and architects are trained not just to design a building properly, but there is a bit of architecture as art. And my personal philosophy there is that that's the biggest problem with architecture, is that it's art. And it forgets about how to really take care of the people and the planet. Once it does that, then it can become art. So architects are taught this whole process about how to deal with permits and legal things and business things. And so typically a floor plan, a footing plan, a framing plan, sections, elevations, a site plan, and that pretty much covers the basics. Some counties require way more, like a 4-bedroom concrete building we're doing in Wrightwood, California, full on Earthship, but concrete. The architectural set is 42 sheets, grading plan, soils plan, a whole bunch of sections of the inside, like 9 different sections of the walls, a lot of engineering involved. And so, but it's all, none of it is really difficult. It's just a process. And fortunately, we've been operating for the last 25 years in Santa Monica and Los Angeles, which is one of the hardest places to be an architect. And so it's a process. It's not difficult, but that permit process has taken us about 16 months. The biggest time factor is the building department and third-party consultants in waiting for things to get done, fees associated with it. But then other places, for example, counties that are farther away from certain population centers, a lot of places in Wyoming and Montana and all that, some places only require a septic permit and absolutely nothing else. We're doing a project in Washington where all like the The guy at the building department said, yeah, just give me a simple hand sketch of the floor plan and a septic permit. And it's like, okay, great. So, but all that being said, getting a full-on, completely off-grid building can be permitted, no problem, in every single county in North America. It's just about meeting all these requirements and putting it into the format that they want. Even 20, 30 years ago, but these days it's incredibly encouraged, and building departments are grateful for it. So they're really working with us and saying, like, do it this way and things. But we get that question all the time: can I get a permit here? And the answer is always yes.
Even, and now I'm curious, because I was in LA for 18 years, and my friends who had built things in LA, that 16 months sounds about right as far as their experience too, just to get permits to start building. Is California coming around on completely off grid? Like, what are the concessions that you had to make on this build?
None. No, there are no concessions, and really, there never really was. There is a federal law that you have to connect, but it doesn't to the grid. But there is no law that you have to use it. So that was the case on a big Earthship we did in Mayaca in Florida, where the power and the water grid was right there to the property. So we had to bring it into the building, but we didn't have to use it. And I went to the state health department to get a variance so that we don't have to do a leach field, because the water table is really high. And our gray water and black water planters, as you know, are completely contained and nothing leaches out. And that was really the only solution to treat wastewater on site, because the water table was so high. And the state health department loved it, and we got a variance. It was pretty easy. There are no concessions. Los Angeles City actually has on their books that they encourage flushing the toilet with gray water. That was 3 years ago. Hardly anyone is actually doing that, because the conventional definition of gray water is right out of the drain, right out of the sink. As you know, our definition of gray water is after the gray water planter. So it's treated and it's clean, and the human eye and the nose cannot tell the difference between that and potable water. So in terms of getting permits for off-grid buildings, there is no issue. It's about the structure. The rammed earth and tires in California would require time and money right now, and we're not going to put that on one client. So we're going through a few projects right now. We're looking at actually doing a Phoenix Earthship in San Diego soon. And so through that, and we're lining up a couple others so that we, and we're also investing in a new structural engineering report. Another client of ours in Oklahoma, we're doing a new structural engineering report. So we're going to put those two things together and then provide that to, and it's a process, and it's going to take a lot of money to get it into the codes and the books in California. But that's the process. That's the only issue. No issues with anything off-grid, catching water, gray, black water, the cooling tubes. None of that are issues. In California and San Bernardino County, where we're doing this 4-bedroom, is very, very not difficult, but incredibly detailed. We like one of the things is the solid waste report, where we have to estimate how much waste is coming off the job before we even get the permit. How much wood, cardboard, steel, metal, all those things. Submit that, they approve it based on looking at the drawings, and then we have to document that when we go and get rid of the materials. So it's incredibly detailed, but it's not difficult, and there are no restrictions against off-grid things.
What is the tires like? So what is their stance on tires? I was under the impression that they just weren't seismically tested for California's earthquake like possibility. Like they're here in New Mexico, I think I think it needs to withstand like a 4 on the Richter scale or something like that. And then like in California, it can get up to like 8 or whatever. I don't know. I'm ignorant on this, but what is the thing around tires? Are they is it the fact that they don't know what they're doing to the surrounding soil? Is it a seismic thing, or what is that?
So rammed earth in tires is not on the books in California. So they can't say yes, they can't say no. It is the building department's job to interpret the code and move the liability off of the county or the city, which goes on to the licensed professional like us, the architect, the contractor, the engineer. So once a set is stamped, the liability stays with that design professional. And once the county stamps it for the permits, it's basically a contract that puts the liability on the design professional. So we have built in over the decades Japan, which then they made us do. My father and went out there to build an Earthship, and they made us do I think it was a 10-inch thick slab under the entire building, and a really big tire retaining wall into the hill. And they've since been through a bunch of earthquakes. I think the first two that happened after that job was done, the slab cracked. Earthship is fine. And as you know, rammed earth and tires, it's like an elephant foot. It's 2'4" thick. It creates a tremendous amount of weight. Earth and rubber does not crack, so it's able to take the vibrations, if you will, of an earthquake. The job that we did in India, they've since been through a couple 8+ earthquakes, no problem at all. And so, but that's the issue. And this Earthship that we're doing in Wrightwood, the structural engineer cost, I think, $7,500 or something, which is like 4 times more than normal. We have to use really, really thick steel in all the concrete and the bond beams. But it's just a bunch of calculations. It's a really big report they do, and for the specific seismic zones. But that's the only reason why we're doing concrete there instead of tires, because it's just not on the books. All the building departments and inspectors and engineers I've talked to out there that we've worked with over the years, they all love it. They love Earthships. They can't wait. They love rammed earth and tires. They can't wait for it to be in the codes and in the books so that they can say yes. It's not their job to right now say, okay, that's great, I understand, and say yes. They're not allowed to think, which is unfortunate. They have to go by the letter of the code, and it's just not in there.
Well, how would something like that change? Like, what do you think would have to happen?
Money. Unfortunately, it's capitalism run amok in this country right now. There's nothing wrong with capitalism in general if it's done right, but it's clearly not being done right. And it would take probably something on the order of about $15,000 for a structural engineer to do all their intense reports, and then we have to get on a shaker table, which they have at UCLA, which costs I think $300,000, and then we have to write the actual code, which we have most of it written, through the tire building code that we have. But that's the process. So in the interim, we're having these structural engineers right now, one in Oklahoma, to give us a new and updated, as you know, the old one that we have, a full-on engineering report. Because all the calculations and the Xerox copies in there are kind of fuzzy. But to do just a new updated one, and that'll be a first step so that we can at least get a permit for a tire building in California with a variance, just like we did on the wastewater treatment system in Florida. So it would be a variance, which isn't that difficult. It's basically 2 meetings with the county to explain it. Here's the engineering report. We show, like I said earlier, that the liability is on us as architects and engineers. And so that's how we're going to get permits at first in California.
And what is the time frame for you? Like, let's just say a 1,600 square foot house, like a 2-bed, 2-bath sort of standard. What is the time frame for that being built? And maybe we won't talk about California because the time frame from permitting to breaking ground, that seems like a lot. Like that's got to be like the most, right? Like the longest time frame. What's the average time frame from, pulling your permits, submitting your drawings, getting your permits, and then starting construction? Like, as far as how long does the permitting process take in most places?
Well, California is anywhere from 9 to 14 months, like the Wrightwood Earthship we're doing. Taos, New Mexico is 2 weeks. Right. So it's just different. Los Alamos, a project we're doing, that's a 3-day turnaround once we submit the drawings. The state of New Mexico that we just pulled permits for, that was a 2-day turnaround once we submitted drawings. So then, you're looking at the process of creating the drawings and how long does that take? Another project we're doing in Georgia is, some clients, they're like, I just want a building and this is it. And they're not too particular. Some clients are like, which is fine either way. It's all good. And I appreciate some clients who are like, I want it this particular way, or I don't know what I want and I need help in determining, for example, what rustic modern means, and going all over the materials and the aesthetic. And we do renderings and photorealistic renderings so that in a 3D space, so clients can really understand it, because it's a giant step. It's a 6-figure project. Usually it's the most intense, biggest thing that a client will ever do in their life. So we need to take time with it and honor that and be thoughtful and caring about it. So the drawings are roughly that. The permit process can be that long. But, in some places, it's like Taos and Los Alamos, it's a couple days.
Now,
and then the build time.
Oh yeah, and
right.
Build time.
A typical 2-bedroom can be a 5-6 month build. It can get into 9 or 10 months depending on finishes, and if the budget is tight, then it can take a little longer. But time ends up being money, so it really does depend if we have enough budget to throw more labor at it. And when we have the academy with students to wrap around it also, it saves a little bit of time. It's a wash in terms of money. So a typical 2-bedroom, depending on the design and if we're building in winter or summer, can be 6 to maybe 9, more like 8 months.
Yeah, because that's another thing that you have to think about is the weather. Like you got to think about, the building is maybe vulnerable in certain stages to getting rained on, and weather affecting the building materials. What do you think about, like, what's your goal as far as when you start a building to get to a certain point before, it gets rained on? Is that something you think about?
Oh yeah, weather is absolutely critical. You always have to watch the weather, especially when you're living in an Earthship or any building that relates to the sun and the wind and everything. So here in Taos, we get monsoons, as you know, in August, and you want to try and time it so that you can either be enclosed by then and protected, or kind of not have the building enclosed or exposed during the monsoons. And when we're building in the winter, it's really harder on the crew, because it's hard building in freezing temperatures, right? So, but we've done it many times before. A remodel we're doing in Los Alamos, where we're going to pop the entire roof off and put a proper roof on there, because right now it has no insulation, which is crazy. So that is timing. We just have to stage it right, have all the materials, watch the weather, take the roof off fast, and put the other one on as fast as possible.
Wow. They had no roof insulation.
None. It's totally crazy. And so the building was way too warm, because all the heat from the sun just came right through.
Down, and then it must be freezing in the winter.
Right.
Jeez. And typically, what do you as far as the R value for a roof, which, could you explain R value? And then also, my question is, like, what R value typically do you like for a roof, and does it depend on the obviously it depends on the climate, but what do you have to say about the R value?
So I would do an R50 in a roof in any climate. In a place like Taos, New Mexico, or Canada, or Alaska, where we get really intense and cold winters, 10 below or something, it's still an R50. You want to hold all that temperature that you do on the inside. And then in Taos, we get a ton of sun. So Taos is the solar capital of the world. So you want to keep all that heat out. So what insulation does is it doesn't completely prevent, but it basically keeps temperature from moving from one side to the other. It's a material with a lot or as many little air pockets as possible, which industrial hemp does the best because it just naturally has the most amount of air pockets in it. So we've recently switched from fiberglass bat insulation to industrial hemp, and the R value is higher, not crazy big. But typically what we do in the roof is 2 layers of 4-inch rigid polyiso, not the best material in the world, just like concrete, but not much of a choice. Energy codes also require that. Fortunately, in years past, they didn't. And so that's in the roof. And then in a building like an Earthship or most sustainable off-grid buildings that have a lot of thermal mass, which holds temperature, you want insulation on the outside of the thermal mass. We have an earth berm, as you know. So there really isn't much insulation in the sidewalls because of the earth berm, so we just put it all on the roof. But buildings that we don't have an earth berm for, we'll do a minimum of R30 in the walls. That's even a little light. The more insulation, the better, and that just goes on budget. Ideally, yeah, you want to have an R40 or even, if you can, an R50 in the walls. It's just going to mean that building is going to stay that much more comfortable, but it depends on budget. So an R30 is minimum, and fortunately that is also in the energy codes in New Mexico and California. California has Title 24, and they model everything, and our buildings don't fit because they're way ahead of everything. So they're just like, okay, here you go. But that's the insulation in there. Those are the minimums. And then U factors on windows, pretty much a minimum of 0.29. It's just a measurement of how temperature moves through. And so those are the minimums.
Okay. And for people that don't know what the R value is, it's the number is an amount of hours that it takes from
something like that. Yeah. I mean, it's similar to the fire hours, of a material,
of like a door or something.
Right.
Yeah. And then, that's on the hemp insulation, is that that's not rigid. That's it's like
bats.
It's like bat insulation, but it's made out of hemp.
Yeah. It's like 95% hemp.
Okay.
The rigid quote unquote hemp that they have is 30% hemp. And the rest is just stuff, cotton and other things that we're not willing to go with because there's insecticides and all those things and glues on the rigid. So it's not there yet, but we are working on a couple of options to grow industrial hemp on thousands of acres here, ship it to a facility to get it processed, and then ship it up to Hempitecture, which is the company we're working with, to get that rigid hemp so that it's 70-75% hemp and more, and then it's rigid, then it's there.
And that could be used in place of polystyrene,
polyiso and polystyrene.
Yeah, because the polystyrene, and that's the fiber, it's a fiberglass based insulation, right?
Bad stuff.
Yeah,
you have to wear a mask and all that, or should.
And then the polyiso is or polystyrene is a styrofoam based rigid, and
a little better.
A little bit, yeah, not as toxic to you, but it's also I don't know, does it release I don't know. They always told us when I was growing up, like when you break a styrofoam cup, it releases, bad stuff.
Yeah.
But the reason why we use those insulations is because they just outperform the more natural insulations. Termites don't eat it, like bugs don't eat it, and it just holds up to weather and all that stuff better, unfortunately. But that sort of stuff is, we're always trying to look for new materials that are more sustainable, obviously. It's just we haven't found anything that performs as well, over the long haul, I guess. Right. What do you think about plastic as insulation? Earthships, when we go abroad, a lot of times, especially in Puerto Rico and Haiti and stuff, we're using found plastic crunched down in cavities on the roof and even in cavities around the building. And that's what we're using for insulation. And, the long-term durability of that, we're still finding out. It's all an experiment. But what do you think about plastic as insulation, possibly eventually? What's to stop us from starting to use that in the berm instead?
In the berm?
Yeah, like instead of burying polystyrene.
Oh, right.
What would we need to do to do
To
that?
get rigid plastic insulation. Yeah.
Yeah.
So
yeah.
When we were in India, we paid the kids, I think it was like 1 rupee for a bag of plastic bottles, and we did the same thing in Haiti also, and put it up in the cavity of the roof. Plastic should be anywhere except in landfills in the streets. So and they were collecting some of the foam and other things that got in there, put it in bags, and like you said, compressed it and put it up in the cavity of the roof. And so insulation is just stuff with a bunch of little air pockets. And when you just kind of compress plastic bottles and things under that situation, the air pockets are rather large, so it's not ideal like bats or something else that's a made product, but it still functions, and it's still taking a waste thing that is a problem in the landfills and all that, and keeping it out and putting it into this building where it's going to be inert, it's sealed away, it's in plastic, and then another layer of plastic. So it works. It's a good solution, especially in a disaster relief place, in a disaster place where we can get that plastic off the streets and out of the landfills. So that definitely works. And we also take all those plastic bottles and put it at the bottom of the gray and black water planters, just for housing for the good bacteria that eat the bad bacteria. It's not a lot, but it's something. And then there's things like, I was talking to Mark Goldman over at UNM Taos, who runs the Green Building Program, about compressing plastic into bricks, like Lego bricks, and fitting it all together, or compressing it into 2-inch and 4-inch rigid boards. And that's viable. It's been done. We were talking to Mattel. Mattel.
The Barbie company.
About their because they're using plastic in all kinds of things, and the cars, they make those little Hot Wheel cars also, and so they have very large facilities. I think 9 of them around the world, and they have a lot of plastic coming out. So we were consulting them about what to do with it, and it is compressing them into bricks. So that is there, and it's out there. It's still kind of in the research and pilot project phase, but that is coming, and it's coming very soon, so that these bricks can be used. And the using that as 2-inch or even 4-inch rigid board as the thermal wrap in the earth berms of Earthships, It can work. It can be something. It's probably not gonna work as well as foam, because that's actual insulation, whereas plastic is compressed, and we'd want to keep some air pockets in there so that it actually performs. So that's just talking to the facility. I'm sure they can figure out how to do that. Mm-hmm. But again, it is better there than it is in a landfill. Yeah,
I agree. I wanted to talk about the versus So Earthships and Pangea, we build eco homes, basically, off-grid eco homes. What are the difference? What are the stick frame building costs in a lot of states, we have a list in the visitor center of, like, state by state, like what are the average stick frame, traditional building costs versus, and we obviously know what our numbers are. What are, in your experience, like stick frame versus eco homes? Because in a lot of states, what we quote people, which is $300 a square foot for the, for the our lowest cost model. We're competitive in some areas, but in a lot of areas not. But what is the I guess what is your experience with, like, stick frame costs versus your building costs per square foot, and what do you think about, like, how do we make that number go down? How do we make eco homes cheaper than traditional building?
So stick frame buildings on average are $200 a square foot and less, and lower. Some places you can even get down to $165 or $175. We're doing a project in Joshua Tree where we're doing 2x8 completely frame, and we're doing it 2x8 instead of 2x4 or 6, so that we can get the R values, the increased R values. And we will always do stick frame because we need to stay on top of that and know it, because we can't talk about something and its benefits or negatives without knowing it and doing it. Otherwise, we have no idea what we're talking about. So we're always doing that. We're always trying to make them as environmentally friendly as possible, even though I can't stand building buildings out of frame. It burns, it rots, you can drive your truck through it, it's bad for the planet. Trees are our lungs for the planet. It makes no sense. But I understand how we got here and why, and it is what it is. So, but yeah, Earthships and other sustainable off-grid buildings that have all the systems, typically, that's what we do. We start at $300 a square foot at that early point, like we were talking earlier, when we first start talking to a client, and the design and the aesthetic, adjust that cost per square foot as we're going through the design process. But the difference is that building, as you know, comes with all of its off-grid systems. So there's little to no utility bills. So over time, that sustainable and off-grid building, Earthships and other types, are way more cost effective. Stick frame buildings are way more expensive, especially when you get into the true cost about how it affects society and the pollution and healthcare and all those things. But the upfront cost, yeah, they're cheaper, but you get what you pay for. You get, and sorry if I'm offending anyone, but you're getting a junky piece of junk house.
Old technology, basically.
It's absurd. It's totally crazy. It makes no sense from every way you look at it. It makes no sense to build with frame. But like I said, we're going to do it. We're going to make them as eco-friendly as possible, because we can't talk about something without doing it. So we need to understand it.
Yeah.
And then how do we make sustainable off-grid buildings more affordable so that it can get close to that $200 a square foot? Well, it's not so much about the structure. It's not so much about rammed earth and tires. That is very affordable. Dirt is from the job site, so you're paying an excavator, or maybe you have to bring some in. Tires, you just pay a little bit of labor to go get tires from the landfill. The real cost is the systems and the finishes, and depending on how big the greenhouse is, which is framing, which should be done more often with metal studs instead of wood, for obvious reasons. But so there's not really much to do there other than 3D print the house. And as we were talking before, that makes it faster and way more affordable, so that we can still do Earthships with thermal mass, 10-inch thick walls, can do an earth berm or not. But I think getting to $200 a square foot is going to be pretty easy. I think we can get even lower, especially with volume.
Mm-hmm. Yeah, that's the one thing that, Earthships is, Earthship Biotexture is such a small company. We don't operate at scale. And, if we did operate at scale, which I think Pangia Builders is, you guys are going for that. We can get, a design that's got standard parts to it, like standard trusses or standard, like prefabbed, window boxes and all that stuff that can just be made at a centralized place that can run efficiently and,
Right.
could be run on biofuel and all that. And we could just get stuff, you can build a house faster, less labor. Yeah, I think, if we could get down to $200 a square foot and be competitive with, the stick frame and the houses that you just plug into the grid, that's the thing is I don't think that people are just going to, out of the goodness of their heart or their love for the planet, start to reduce their carbon footprint or their reliance on the energy grid.
Yeah, nor should they have to.
Exactly. Being pragmatic about it.
That's our responsibility as designers and builders to make sure that they can have their cake and eat it too.
Yeah.
But yeah, my father and I have been talking for decades. This has been one of his hopes and dreams for forever, is to stamp these buildings out like the Model T Ford. Just boom, 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 a whole bunch of them. It's the same. It's a Lego kit, and just like a Lego kit, and that's a great solution. And it could definitely work. We just have to get there. And I mean, no matter what, I'm going to make that happen. I don't care what it takes, so that he can see that. But when you look at it, we've been doing these buildings one at a time, very slowly, no construction yard, no template, nothing. It's every single thing is a very unique one-off thing. And it's still $300 a square foot. That's giant. That's a huge accomplishment. You do that, but with, custom conventional homes, and they're like $500 a square foot, $600 a square foot with no systems. So $300 is a crazy, crazy bargain. But then you're right. When we get into scaling and volume, where we have everything dialed in and we're doing very large materials orders for 10, 20, 30, 40 homes at once, we start to get volume pricing, and then we're building 200-300 at once. We're working on a project here in Taos County where hopefully, fingers crossed, we can get a project where we're going to be building 200 affordable homes all at once, and that's when we're really going to drive the cost per square foot down. 3D printed, probably around 175 maybe a square foot, so that they can be rented at like $700 a month. But that's when you do it. You have to scale. It's the only way. You can't do one-offs.
5 years from now, where's Pangia Builders? What are you guys? Where's Pangia Builders? What are you guys up to?
Pangia Design Build, yeah. So 5 years from now, hopefully we have a large network of organizations and designers and builders and a lot of companies who are doing this, so that we are not the only ones. That's absolutely mission critical, which is why we have the Academy, which is why we want to partner with everyone, work with everyone, learn from everyone, and build up this network, so we have a lot of organizations spread out around the country and the world that does this. Because, when we send a crew from Taos, New Mexico to, say, Oklahoma or Costa Rica or Greece or wherever, that's airfare, that's accommodations, that's food, that's a pretty hefty premium to put on top of it. So that's absolutely, absolutely critical, and we're doing everything we can so that we can so that we can set that up, so that we have many organizations doing this everywhere. But for us, we're setting up on a pathway to build a lot of developments around the world. I call them embassies of sustainability, where we have small, medium, and large communities all over the place, starting with a few here in Taos, so we can, kind of get our thing together so it's all smooth, and then replicate that in Georgia and California and Texas, and so that people don't have to travel all the way to Taos to stay in an Earthship or a building like that to understand it, and people who want to get into these buildings, like we figured that out about 20, 25 years ago, a building that will do all these things off grid and everything. but then how do we get land? So that's why we did the Greater World and Star in these communities. And so we need to do that all over the place. So hopefully in 5 years we have 5 of those, and we have 10 or 20 different organizations doing this, and we're all learning from each other. Something like that would be nice.
Yeah, very cool. I mean, now you just mentioned Star and the Greater World and all that stuff, and I actually, I wanted to ask you about, because you basically in all the old pictures with, all the way back to like the castle being built, out here in Taos, and what was your favorite sort of era of Earthships while you were, still young and still working, with Earthship biotecture? Like, you worked up at Reach, which was, that kind of a marvel in sort of human effort, and you worked, well, you watched your dad build out the castle compound with the turbine house and the pyramid and all that. What was your favorite sort of build to be a part of, I guess?
Yeah, I mean, pounding tires at the castle, I don't know, I must have been 10 or something. I don't remember the exact age, but that was a lot of fun, pounding the tires around the giant dynasphere that was there. The first cruise that my father had in the late 70s, mostly women, and they're actually the ones that came up with the idea of pounding tires with a sledgehammer instead of using your hands, like on the Hobbit house in Kenyon, where that was just all pushed in with hands, so the tires were a little mushy. Still works, still great. That was, I mean, I'm sure it was because I was young and, just a little kid and looking up and seeing all these crazy things. So I'm sure that kind of fantasy thing had to do with it. But that was like these magic times. And then there's been a couple, I call them eras with the whole operation and the company, when we used to be solar survival architecture, and we would go up into the mountains almost every weekend. We called it a peak a week around here, and the entire company and the whole crew went up there. And we were doing a lot of disaster relief things. I mean, really, all of it has been absolutely thrilling and the best. And I've made, great friends and relationships and brothers and sisters. It's hard to pick one era or one time. When we started Reach, that was pretty crazy and magical and ambitious and aggressive.
Can you describe for people that don't know what we're talking about with Reach?
Reach stands for Rural Earthship Alternative Community Habitat. My father likes those. What do they call them?
Acronyms.
Acronyms, and he likes those a lot. And so that was just to show and prove that we could do these buildings with zero infrastructure and no big truck bigger than a Toyota truck, which we literally killed a couple trucks doing that on a really extreme place, literally about 50-degree slope, and it works. It's great. And so that's a 55-acre community up there, and then STAR is called Social Transformation Alternative Republic, and we like to joke that we called it a republic so we can secede from the Union one day. But, that was decades ago. We're not, all, buck the system thing. We got to embrace it. And so, starting the Greater World was amazing. And just, so many people who have worked with us, and, that I'm just missing terribly now. Just thinking about a lot of people who are all over. So it's probably not, there's certain projects that have been magical and amazing, like India, Haiti, but I can't really pick one era, and the beginning in the 70s was magical, but that was probably because I was so young. But that was amazing, because my father we'd be building and designing and in the office by day, and then he'd have a band at night that he would go play music around town at various places. And here's my dad doing something completely different that I'm seeing others just in awe of, and then he's like this rock star guy. And it was like being like 9, 10, 11 coming up in that, it was just like, damn, this is pretty fun.
It's pretty wild. Yeah. I mean, yeah, it's like the amount of things your dad was up to in those days was a lot. Like, I mean, just, the Earthship volumes, he pumped those things out like year after year after year.
Yeah, we had a big team that put those books together and the drawings. And I remember Claire Blanchard was doing a lot of the digital graphics before Photoshop and all. And I remember her drawing pixel by pixel on like,
oh wow,
something MS Paint or something on those old Macintosh.
Yeah. With a mouse.
Oh yeah, it's totally crazy. It's totally bonkers.
Wow. Well, let's see what we're at here. Where's that? 9 minutes left. Let's see. Well, how do we? So, I mean, this is a very general question. Well, first, your dad has a great quote, and it's he likes to say like, we're choking ourselves with our own hands, and then we're passing out, and we're doing it again. We're not dying. We're just suffocating ourselves slowly, and it's just like, and he says that in regards to building codes and the current dogma, but I mean, and I think that's exactly what we're doing in so many different respects. The wars that we're involved with, the fact that we're even talking about World War III right now, and nuclear war. And, what do you think we need to do to change that?
It's really easy. It's a simple choice. We're stuck in this rut of momentum about how things are supposed to be. You're supposed to grow up, you're supposed to go to grade school, you're supposed to, pick your electives, you're supposed to go to college, you're supposed to. And we are all magical beings, and we just need to listen to our inner voice and be honest and truthful with each other, but first with ourselves. Only then can we really have the safety and the understanding and the confidence to make these decisions that we know we all have inside. How to treat people, how to get up in the morning, what food to buy. We make our vote not in the election by how we spend our money. And we're just stuck in this thing, like my father is saying, where we are hurting ourselves in this process of how we go through blindly and numbly through this day-to-day thing, this 9 to 5, work, pay the bills. You do that year over year, decade over decade, and then you end up like, okay, well, shit, here I am, kind of stuck, and what did I do with my life, So I would say the things that we're afraid of, do them. The things that we want are on the other side of our fears, and embrace the storms. Say the weird things, do the crazy weird things. Tell that person you love them. Do the thing that you wanted to do. Go out and travel. Get uncomfortable. You got to get uncomfortable. As soon as we're comfortable, we lose it. And don't be afraid. 90% of our fears and our stress are all made up. So definitely those things, and they're easy to say. And I'm not saying I can do them. I struggle with these things every day. But show up for your kids, for your partner. Show up at town meetings, at county meetings. Make your voice heard, and be absolutely conscious of everything that you're doing, because then things can actually start to change. We're all after taking care of ourselves and making ourselves happy. Well, that's not the way it works. You can't make yourself happy. You can't make yourself safe. The only way you can do that is when you go out and give happiness to someone else, and be with someone who is struggling and just be there with them. Then it's going to come back to you 100-fold. So those are the things I would say we need to do. And then we were just at a town council meeting last night, and we were talking about what's the most sustainable thing we can do. And, doing lectures all over the place for so many decades that I've done, I get that question a lot, and people are usually, okay, well, it's recycling water, or it's solar power, or something like that. Well, all those things are great, but the real thing is we need to support and empower women. That is literally the most sustainable thing. That's what the United Nations came up with, and a lot of governments and agencies and think tanks. And it makes sense because women raise us. They make our house a home. They make everything real. And when we support and empower women, we all get raised right. We get raised better with more thoughtfulness and compassion, and then everything just happens from that. So I know it's a long answer, but that's my answer.
Well, I love the answer. One of my favorite quotes, and it's actually up in your dad's office somewhere. I don't know who put it up. It could be anybody. But it's basically, be the change that you want to see, so we embody that change and we're living it and we're doing it. I mean, that's one less person we have to worry about, which is yourself. And so, I'm totally on board with that.